Okay, so now we go to this topic of standard deviation, right? So because due to time constraint, I couldn't go through in class. Alright, so let me go through this standard deviation in this video. Alright, so standard deviation, what is standard deviation? Basically, standard deviation tell us the spread, okay, spread of our data. Okay, so I have what kind of data? So example is I have the number of, the income of a country. Okay, I want to calculate the standard deviation. Or another data set is the results of our upcoming test, right? Okay, term 1 test. Alright, so let's take an example of term 1 test. Okay, so this term 1 test, there will be 4 classes. Alright, so there will be EMATS class A, B, C, and D, right? Yeah, how do we compare? Okay, besides comparing the mean, the average of every class results, I can also calculate the standard deviation of the results. Alright, so so let's talk about class C, okay, and class D. Okay, so the standard deviation, what does it tell me? Okay, so in the example, class C has a standard deviation of maybe 2.2. Okay, so standard deviation has no units and it's always a positive number. Alright, so class D has a standard deviation of maybe 4.5. Okay, so what does this tell me about class C and class D student profile? Right, so for class C, if class C has a lower standard deviation, I can say that the results are less spread. Okay, and I can conclude that the students are the math skill of the students are relatively closer. Okay, less spread. Okay, for class D, if the standard deviation is higher, it means that the results are quite spread out. So got people get 90 of 100, got people get maybe 20 of 100. Okay, so I can conclude that some of the students are super good in EMATS, some of the students are weaker or quite weak in EMATS. Okay, so this is how I can conclude. So the spread is bigger. Or another word that they like to use in EMATS is consistent. If my standard deviation is low, means that I'm more consistent. Okay, if my standard deviation is high, means I am less consistent. Okay, so another example is the income. Alright, income. So I have country A, so maybe I write here. So I have country, let's just say Singapore versus Malaysia. Okay, and I have the data of all the income that is earned by all the Singaporeans. Okay, and let's just say I have a standard deviation of 5.0, and for Malaysia I have a standard deviation of 3.0. Okay, so I can say that Singapore, the standard deviation for Singapore is higher. Okay, so the spread is higher. Okay, so of course the income inequality will be higher also. Quality is higher. Okay, so there will be people who earn obscene amount of money, and people who earn very, very less. Okay, and for Malaysia, the standard deviation is quite low, right? So I can say it's less spreaded, and the income inequality is low. Okay, inequality just right. Alright, so of course I can say they are more consistent, right? They are more consistent, right? Okay, so this is the idea of standard deviation, right? Okay, so of course standard deviation, I need a formula to calculate, right? Okay, and the formula is this. Okay, so of course remember your sigma. Okay, sorry. Okay, so your standard deviation has a formula of this. Okay, right, so you can see there's a very funny sign, this, right? This is what we call summation. Summation means adding up. Summation, right? Sum, right? Just add up everything. Okay, x bar is our mean, represents our mean. Okay, and n represents the number of data I have. Okay, so in the example of set 1, okay, so I have 8, 9, 10, 10, 11. Alright, so how many data set I have? There will be 5 data set. Okay, this is the first step you need to understand. Second, I need to calculate what is the mean. Right, so mean, this is quite simple, right? This is just lower secondary stuff. Okay, so first of all, we add up everything. 8 plus 9 plus 10 plus 10 plus 11. Okay, divide by the number of datas. Okay, so let me add up. Okay, so my answer, my mean is about 9.6. Okay, so this is very important. The second step is very important, right? Okay, let's go to the third step. Okay, so the third step is more tedious, right? So I need to use bracket x minus our mean, then bracket square. Okay, so remember, why do we need to square? Because my standard deviation is always positive. Because later I need to square root. Square root something, the something need to be positive, right? So first of all, x. Okay, so my first number is 8. Alright, so I use 8 minus away my standard deviation, my average. Yeah. Okay, then we square. Right? Haven't done yet, right? So we need to use every number in the data. Okay, second number will be 9. Okay, 9. Minus away my 9.6. Then we square. Right? So third number will be 10, right? Okay, 10. Okay, of course minus away my average. Okay, fourth number will be also 10. Okay, 10. Okay, so the last number will be 11, right? Okay, so 11. Okay, yeah, then after that we just put into calculator to calculate what is our number. Okay, so I get a value of 5.2. Right. Okay, yeah, so now we go to our final step. Alright, so final step, we go back to our formula, standard deviation formula, right? Okay, the summation of the bracket divided by the number of data that I have. Okay, and then of course, not to forget your square root. Alright, so my numerator, which is the top part, is 5.2. My denominator is the n, right? The n is just 5. Okay, and square root. Alright, 5. Okay, so I should get a value of 1.019803903 and just go to 3SF 1.02. Alright, so this is my standard deviation, my first data set. Alright, so let's go to data set number 2. Okay, so data set number 2 is, let me erase all this first. Okay, so data set number 2 is 6, 8, 9, 10, 15. And first step, we need to calculate our n. Okay, so there will be 5 data set. Second step will be the so-called x bar, right, or the average. Okay, so you just add up 6 plus 8 plus 9 plus 10 plus 15 divide by the number of data set, 5. Okay, so what you will get is so you'll get about 9.6. Okay, and if you are observant enough, you can see that our mean for the first data set, which is 9.6, right? And the mean for the second data set is also 9.6. Okay, so sometimes mean can be the same for both cases. Alright, so that's I mean, then we can't really compare. Okay, what we can compare is the standard deviation. Okay, so the third step, summation x minus x bar, then bracket square. Alright, so just calculate accordingly. Okay, so first of all, let's put the first number 6. 6 minus, okay, our average 9.6, then square. Okay, go to the second number, 8 plus 8 minus 9.6. Okay, square. Okay, third number, 9. Okay, 9 minus 9.6, then square. Okay, fourth number, 10. Okay, 10. Okay, so this is the fourth number. Our last number will be 15, right? Okay, so just use 15. Okay, so I should have five brackets. Okay, so let's calculate accordingly. Okay, so you should get a value of 45.2. Okay, then of course, let's not forget our last step, calculating our standard deviation. 4. Okay, so standard deviation, square root something like, okay, square of my 45.2 divided by my number of data set 5. Okay. Okay, I should get a value of 3.006659276, or round off to 3SF, 3.01. Alright, so you can see there's a higher standard deviation for data set 2, right? Okay, so it means that my data are more spread, there's a higher spread. And what do I mean is less consistent. Okay, less consistent. Okay, less consistent. Alright, okay, so yeah, so this is my set number 2. Okay, by looking at just the number, you look at 6, 8, 9, 10, 15, the numbers are quite far apart. I mean, like relatively far apart, right? Okay, as compared to my 8, 9, 10, 11. So this for set number 1, the number, by just looking, you can see that the numbers are more closely I mean, their difference is not so big, right? They are quite near one another, right, compared to my set number 2. Okay, so these are for just a very small number data set. Okay, so in the event that you have a very big data set, okay, or what we call the group data,